Hello everyone, today we will show some workings on a number of questions that are possible for your finals. A farmer needs to build a pen to hold his sheep and his pigs. He wants to keep the sheep and pigs separate. He plans to build a rectangular pen, so there's a rectangle right there. You draw your diagram. And a divider fence parallel to the width down the middle. So he needs a divider fence right here, parallel to the width, and that's down the middle. So this distance here is L, right across, and then these are widths. Okay, so you have, for the length of the fence is 2L, and then for the width you got 3W. And here's 900 feet. So 900 feet of fence. So 2L plus 3W is equal to 900. What we want to do is I want to solve for one of these variables in terms of the other and then say something about the area, because this, what we're doing right here, is like the parameter. Okay, so let's solve for W. So if you subtract 2L from both sides, you have 3W be equal to 900 minus 2L, right? And then if you divide by 3, you will have W will be equal to 300 minus 2/3 L. Now let's take a look at how we find area. Area is equal to length times width, right? So if we plug in or substitute what we have for width here, we can write this formula as L times 300 minus 2/3 L. So expanding this would be 300L minus 2/3 L squared. This looks somewhat like a quadratic, and what we do know about maximum, we want to maximize the area. So to max the max area, then your L here at the maximum or at the vertex would be negative B over 2A. Right, whereas we can look at this is your A and your quadratic, and this is your B. So if we plug those in, we have negative 300 over 2 times A, which is negative 2/3. And so if we work this out, you should get your L being 225 feet. Now, we want to find the dimensions that maximize the area. So let us find the width. For the width, we can go back to what we had here. Width was equal to 300 minus 2/3 L. So that would be minus 2/3 L, which was 225. And then the width would be equal to 150 feet. And so we found the dimensions that maximize the area. The dimensions that maximize the area BL is equal to 225 feet and the width would be 150 feet, and we are done. Okay, let's look at another problem real quick. Let's look at number 7 on the sheet. Find the domain and range of g of x is equal to 2e to the negative x plus 4. And what you might want to do, if you recall our e of x function. Just remember our original e to the x function is stretching that by 2, you're flipping it and you're shifting it up 4. So new asymptote will be up 4. And then you could just kind of somewhat sketch a graph. Y equals 2e to the negative x plus 4, right? Notice here your domain is going to be negative infinity to positive infinity. And your range is basically a shift upwards from your original, which would be 4 to infinity, right? Your range would be 4 to infinity. Positive infinity. Now show that g of x is 1 to 1. Again, if you sketch the graph, you could just say it passes the horizontal line or vertical line test and the vertical line test, both horizontal and vertical line tests. Algebraically though, part B algebraically, you want to use the idea that if g of A is equal to g of B, then A equals B. And so what you want to do is find two x values, A and B. So let x equals A, then 2 e to the negative A plus 4, and set that to g of B, which would be equal to 2 e to the negative B plus 4. And then do some algebra. See if A equals B. So if you subtract 4 from both sides, you end up with 2e to the negative A equal to 2e to the negative B. And then if you divide both sides by 2, end up with e to the negative A equals e to the negative B. And then if you take ln both sides, what you have is negative A equals negative B. And of course, negative A equals negative B. Divide or multiply by negative, then A equals B, and you've shown that it is a 1 to 1. Okay, what is g inverse of x? And find the domain and range of g inverse of x. Now remember the steps for the inverse. Start with your original function, g of x is equal to 2e to the negative x plus 4. Then you write y is equal to 2e to the negative x plus 4, then you interchange the y and x, so you have x is equal to 2e to the negative y plus 4. And then you do algebra from here and then take ln at some point. So x minus 4 is equal to 2e to the negative y. X minus 4 over 2 is equal to e to the negative y. Take ln of both sides. You have ln of x minus 4 over 2 is equal to negative y. So then y will be equal to negative ln of x minus 4 over 2. And so your g inverse of x is equal to the negative ln so write this properly, g is negative 1 of x, ln of x minus 4 over 2. For the domain and range, since we found the domain and range of 2e to the negative x plus 4, then you just interchange the domain and range for this. So domain would be negative infinity to positive infinity, and the range would be 4 to positive infinity. Show that g inverse of x is equal to part D, which is C up there. G inverse of x of, the g inverse of the g of x equals x, right? So one way to do it, just plug in the x into the g of x into the g inverse function for x. So that's going to be the g inverse of 2e to the negative x plus 4. And so you plug in that for So it's going to be negative ln of 2e to the negative x plus 4, then minus 4, all over 2, and then do some algebra there, negative ln of 2e to the negative x over 2. And so that's going to be negative ln of e to the negative x. And so ln and e undo each other, so that's going to be negative of negative x. So that's going to be equal to positive x, and we are done. Okay, so we've finished working on that. Let us look at number 10 and then 13. Number 10 asks us to solve this guy, 10. Number 10 asks us to solve 3 to the x plus 12 times 3 to the negative x equals 7. What you want to do with this, do not go ln just yet. Look at 3 to the negative x and 3 to the x, and we want to transform this a little bit by multiplying through everything by 3 to the x. So what we'll have is 3 to the x squared plus 12 is equal to 7 times 3 to the x, and then do some algebra here. 3 to the x squared minus 7 times 3 to the x plus 12 equals 0. And then do a u substitution. So make u is equal to 3 to the x. So u squared minus 7u plus 12 is equal to 0. And then we can apply a quadratic formula. So let this be a equals 1, b is equal to negative 7, and c equals 12. And so then u will be equal to negative b, which is negative of negative 7, that's 7, plus or minus the square root of negative 7 squared, that's going to be 49, minus 4 times 1 times 12, that's 48, all over 2a, which is over 2, and so that's going to be 7 plus or minus 1 all over 2, which is going to be 6 over 2, or 8 over 2. It's going to be equal to 4 or 3. So then u is equal to 3 to the x, so 3 to the x means that 4 is equal to 3 to the x, or 3 is equal to 3 to the x. So from this you can clearly see that x equals 1. And then for this you can take ln of both sides, ln, and so what you will have is ln of 4 is equal to x ln of 3, and divide through both sides by ln of 3. And so you'll end up with x is equal to ln of 4 over ln of 3. So we have two answers. X is equal to ln of 4 over ln of 3, and x equals 1. So that's your two answers right there. Okay, so let us look at number 13. Find all the solutions. Number 13, find all the solutions of ln of x minus ln of x minus 6 is equal to 3. And do not just take e all through here. Apply the subtraction property of logs. And so what you do is ln of x over x minus 6 for the subtraction of logs is equal to 3. Now you can apply e. And so if you do e to the ln of x over x minus 6, that's just going to leave you with x over x minus 6 is equal to e to the 3. And then the rest is just algebra. Multiply both sides by x minus 6 times x minus 6. And then what you will have here is x is equal to e to the 3 times x minus 6. But then you have to do some distribution. X is equal to x e to the 3 minus 6 times e to the 3. And then bring the x's over and do a bunch of algebra. So we end up with x is equal to 6e to the 3 over e to the 3 minus 1, and we are done. I thank you very much for watching, and see you next.